Hello scholars, welcome. Mr. Hinkle here, and today I would like to introduce you to my friend, the universe. The universe? What the heck is the universe? The universe is literally everything that exists in the known and the unknown world. So let's talk about it. Today we are going to introduce the scope, the composition, and the structure of the universe. Cool stuff. So again, definition, the universe is everything that exists. All matter, energy, space, and time. Since the beginning of the universe, 13.8 billion years ago, until the end of the universe at some unknown point in time, everything in the universe, everything that exists is the universe. All planets, stars, galaxies, forms of matter and energy. And we have a specific study of the universe called cosmology, the study of the universe, its origins, and its structure. So while we're learning about the universe, you could say this is a lecture in introductory cosmology. That sounds pretty fun. So what is the universe made of? Well, the things that we can see and measure and record is called matter. I am matter. This table is matter, computer, right? Things that are created of atoms. It is all stars, all planets, all living beings are matter. Well, matter accounts for approximately 5% of the universe because the universe has a lot of space. The universe is so big, it is incomprehensible. And what that space between the planets, between the stars is well, it's these two different items. It's dark matter and dark energy. Probably called dark because when we look up at the night sky, it's very dark. Dark matter and dark energy. We've got some stats here, about 27%. Boom. And then also 67%. So dark energy is a force that exists that we cannot measure, but it must be there. Dark matter doesn't emit, absorb, or reflect light. It's invisible. It's also inferred based on the gravitational effects on ordinary matter. So, in the universe, what we see, what we know, what we measure, what we record is about 5% of what's going on out there. That is truly amazing. There is so much space out in our great big universe. Well, the structure of the universe consists of galaxies. Galaxies are collections of stars. Stars have planets and solar systems. So we have these different types of galaxies: spiral, bar, and irregular. Galaxies are made of stars. And they come in different sizes. Small galaxies, as few as 100 million stars. Medium galaxies, 100 to 400 billion stars, like our galaxy, the Milky Way galaxy. And then large galaxies up to 1 trillion or more stars. So, each galaxy, hundreds of million to billion to trillion stars. That's amazing. But then galaxies form what are called clusters, where the gravity of a single galaxy pulls on the gravity of another galaxy to form a cluster. But then each of these that we see here, each of these lights, that's a galaxy. The James Webb Space Telescope is taking amazing photos, and now it's taking photos out into space that show us some, not all, but some of the billions of galaxies that are out there. So it is, okay, I'm not even going to go there because it's just so incomprehensible. Let's say here's a galaxy, here's a galaxy, here's a galaxy, here's a galaxy, another galaxy, right? Those are all galaxies, and these ones form another galactic cluster. Well, this galactic cluster has gravity, kind of like our sun has gravity that holds Earth in its orbit. Neighboring galaxies, our neighboring galaxy is the Andromeda Galaxy. Neighboring galaxies hold each other in their orbit, and galaxy clusters end up holding or having an influence of gravity on each other, forming superclusters. Large groups of smaller galaxy clusters or galaxy groups. This is amazing. So we have stars. Billions of stars form a galaxy. We have galaxies. Galaxies hold each other in their gravity, lots of them, to create a cluster. And then a galactic cluster will influence gravity on another galactic cluster, forming superclusters. The scope of this is almost too much for me to even comprehend, but it's awesome and I love it. So, the whole universe can be thought about as a spider web, the cosmic web, a large-scale structure. The whole universe has structure, and we call it the cosmic web, where galaxies and clusters form a network of filaments separated by voids. So there is connection between all of these in every different direction, the little stars, forming the cosmic web. The structure, the large-scale structure to our universe is called the cosmic web, made of planets and stars that form galaxies, galaxies that form clusters, clusters that form superclusters. Our home, our star, we call the sun. And around it are 8 planets. We have the 4 terrestrial planets, or rocky planets, Mercury, Venus, Earth, and Mars, an asteroid belt, and then the 4 giant planets, 2 gas giants, Jupiter and Saturn, and 2 ice giants, Uranus and Neptune. Outside of that is the Kuiper belt, another asteroid belt, and the Oort cloud out in deep space. Our solar system is but one star of billions of stars in the Milky Way galaxy. So when we look out at the sky at night and we see all of those stars, all we see is our galaxy. We just see our little pocket of space, the Milky Way. The universe is everything that exists, including our home planet Earth. It's really fun to think about how big the universe is, but it's hard to fathom. I can barely even imagine how big this universe is. In fact, I probably can't. I'm talking about it, I'm speaking about it, but it's bigger than I can even possibly think, bigger than I can imagine. But it's fun to learn about, because learning about the universe, the scope and the depth and the composition and the structure is kind of like learning about ourselves. We're learning about our home, we're learning about this place that we live in. Our Earth is a rock that's flying through space in the totality of everything that exists called our universe. Thank you so much, and I'll see you again.